Good evening, all of you. This is session 10 of the day. Under the theme Advanced in Computational Modeling and its applications in education, health, and social care management. In this session, plenary talk is given by Professor Jakia Hamouch, and invited talk will be by Professor Hamad Daik Asmai. So first, before starting this session,
Okay.
yes, please, Professor, wait. Please just wait 1 minute. Before starting this one, there are two papers from the previous session. There is a paper ID 299, paper ID 267270. If anyone is present here, please raise your hand.
Yes.
There are three papers from the previous session. If anyone is present here, please raise your hand. Okay.
Yeah, Professor, I am ready. If you yes.
Yes, Professor, please just wait. There is two papers from the previous session because the session was too long. So those papers are
Okay.
being presented in this session. Okay. So first there is a paper presentation in this session.
Okay.
Yeah. Paper ID is 229. Title of the paper is Existence and Uniqueness of Solutions of a Singularity Perturbated Volterra Integral Differential Equation with Nonlinear Initial Condition, and will be presented by Y. Sarkar. I request you please share your presentation. Yes, Nimai Sarkar, now you are a host of this and you can share your presentation.
Okay, sir. Let me share my.
The time for the presentation is 10 minutes. Please do precisely. Yeah. Nimai Sarkar, there is no sound from your side. Please share your presentation. Share your PPT. Ali Pacha, your voice is not audible. Please unmute yourself. There is no voice from your side.
Sir, now the voice is audible.
Yes, yes. Now voice is
Hello.
audible and please share your PPT.
But sir, it is not. Hello, sir.
Yes, I can listen to you.
Please allow me to. Please allow me to share. please allow me to share. Only
Yes,
the
yes,
host can
please.
share in this.
Yeah, I make you host. Now you can share.
Sir, kindly, sir,
Dear Sarkar, now you are host and you can share your PPT. I think there is a network problem from your side. You can send your recording to us on my email address. We will consider, okay? Is there paper ID 267 or 270 is present here? Either one of them.
Hello, Professor. Am I audible?
Yes, you are audible. Please let me your UID, paper ID, please.
Actually, it was minus on the first day. It is ICCTM 214, and I was not able to present that time. Can I present now?
Please, you have to wait. Wait, please.
sir, 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 now it is audible.
Yes, now you are audible.
Sir, please allow me to share my screen.
You already allow you. Okay, once again, I am trying. Okay, now you are host. You can share.
Okay, sir.
Yes, please start.
Yes.
Share
Is
your
it fine?
PPT.
Is it visible? Is
Share
it
your
visible,
PPT.
sir?
Please share your PPT.
Yes, sir. Is it visible? I have shared it.
No, right now, no. It is not visible.
Now? Okay, sir. Let me check it. Now is it fine, sir?
No, dear. Dear Sarkar, you can do one thing. You can, okay.
Sir, you please allow me to presentation after one presentation. First of all, just presentation that can I present my screen because there is, I think, there is a issue with my system.
Dear Sarkar, your PPT not showing here. I think they due to network problem, it's not able. You can do one more thing. You can record your lecture, your paper, and then send to us.
Okay.
We will consider. Okay.
Now, sir.
Yeah.
Uh, okay, sir. Sir, after at the end of this, can I present
Yes,
my
yes.
work?
You can record it and send to us right now. We will consider it. Okay.
But the size will be very much.
There is a network problem from your side.
Yes, sir. I'm fixing it up and let know. Okay, sir. Okay,
Okay.
sir. Okay.
There is a paper ID ICCTIM 267. I think you are present in the session. Paper ID is 267. Please unmute yourself if you are present.
Hello, dear Hello, dear professor. I'm ready to present.
Okay, okay, Professor. I let you know that you can start. Now, first, it is requested to all the presenter. You will present your paper after the plenary talk of Professor.
Okay. If
Uh,
you
so you can start, dear Professor, now.
yes, I will start now because my internet speed is very weak. I will start very soon to. I want to share my screen first, but I need to. I need a waiting to host permission.
Yeah, you
Yes,
are a host now.
yes, please.
Yes, I make the permission.
Okay, okay. Let me come to my screen. Uh, which page I need to come to whiteboard or files? Which of them? Screen. I think. Yes, you can see my screen now. Yes, you can see my screen now. Okay. Let me start my presentation. Hello, dear professors and researchers. Welcome to my session. Uh, I will start to talk about quantum machine learning. That is very important topic in the world of embedded systems, FPGAs, microprocessors, GPUs, new kind of CPUs, and more than. So my topic is on the survey about quantum machine learning trends and applications. First of all, I would like to thank from Baba Farid College for giving me this opportunity in order to present this webinar. The abstract of this webinar is about investigating the principles of quantum machine learning, fundamentals of quantum computing and qubits. Also, artificial intelligence and machine learning algorithms will be studied in order to clarify how these mechanisms are connected together. So, first of all, I would like to thank about a full video that we provided with Professor Dr. Hossein Jawadi, founder of Creative Particle Physics Theory, about a sequel of videos about whole concepts of about physics, quantum physics, and you can reach it later by academia.edu and ResearchGate. And for more information about my webinars about machine learning and artificial intelligence, you can find these links that I will share with you about my previous formerly that I had presented earlier. The topic: what is quantum machine learning? Quantum machine learning is a research area that explores the interplay of ideas from quantum computing and machine learning. For example, we might want to find out whether quantum computers can speed up the time it takes to train or evaluate, leverage techniques, evaluate a machine learning model. On the other hand, we can leverage techniques from machine learning to help us uncover quantum error correcting codes, estimate the properties of quantum systems, or to develop new quantum algorithms. Oh, let me tell you about what is quantum about using can I? Excuse me, dear professor.
Yes, Professor, I think there is some network problem from your side.
Yes, please give me a host permission to come back again. Thank you.
Okay, please wait.
Because we have a very
Yes,
big
please, yes,
connection
please
these
continue.
days.
Please continue. I
Okay.
make you host.
Yes, yes. By definition, machine learning is an application of artificial intelligence (AI) that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn from themselves. So the process of learning begins with observations or data such as examples, direct experience, or instruction, or about the initial data sets that we use about training data on machine learning algorithms in order to look for patterns in data and make better decisions in the future based on the examples that we provide. Okay, the primary aim is to allow the computers learn automatically without human intervention or assistance and adjust actions accordingly. So, some machine learning methods are about supervised machine learning algorithms that learn in the past to new data using labeled examples to predict future events. Unsupervised machine learning algorithm is when the information used to train is neither classified or nor labeled. Semi-supervised machine learning algorithms is fall somewhere in between supervised and unsupervised learning, since they use both labeled and unlabeled data for training. And reinforcement machine learning algorithms is a learning method that interacts with its environment by producing actions and discovers errors or rewards. So this approach uses search and delay the reward are the most relevant characteristics or reinforcement learning. Okay, so I have put some links in order to refer for further studied by the audiences. Okay, so the differences between machine learning, artificial intelligence, and deep learning will be based on this. Deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. So artificial intelligence is a broad grouping of technique enabling machines to mimic approach of human intelligence. Program use it, then rules, decision trees, logic, and machine learning, including deep learning, to predict, reason, adapt, and act. So machine learning is algorithms that improve on task through experience and have the ability to learn without continuous programming. And deep learning is a machine learning subset that uses multi-layered neural networks to learn from large amount of data. So, what is neural networks? Neural networks, also known as artificial neural networks, ANNs, or simulated neural networks, SNS, are a subset of machine learning and are at the heart of deep learning algorithms. Their name and structure are inspired by the human brain, mimicking the way that biological neurons signal to one another. Okay, so a neural network is a network or circuit of neurons, or in the modern sense, an artificial neural network composed of artificial neurons or nodes. Thus, a neural network is either a biological neural network made up of real biological neurons, or artificial neural network for solving artificial intelligence AI problems. So the connections of biological neurons are modeled as weights. So we can have weighted neural networks. Connection. So as a linear combination, finally, an activation function controls the amplitude of the output. For example, an acceptable range of output is usually between 0 and 1, or it could be between -1 and 1. Okay, so You will find here kind of neural networks based on the input layer, a hidden layer, and output layer. Input layer and the output layer will be just come in just one layer, but hidden layer can be repeated a lot, can be replicated more and more in any kind of neural networks that you want to define based on your favorite or customized network you need for your model or your data prepared before. Okay, so you can find any information about the neural networks and algorithms for many references. So about using an input, you will find based on W plus beta x divided by magnitude x, that is the delta rule that uses a kind of a function till one, and otherwise it will be ignored. So you can find the delta rule in many references. So this is a single layer of neural networks, and then you will have an output answer. Okay, so and you can define your neural networks based on the backwards error propagation with weight adjustment, and based on the forward error forward networks that you can both of them that is a kind of learning process, supervised process, and that you can consider for any kind of network that you will define it. Okay, so uh, two hints that is needed to say. Note also that within each hidden layer node is a sigmoidal activation function which polarizes network activity and helps it to stabilize. And also back propagation performs a gradient descent within the solutions a vector space towards a global minimum along the steepest vector of the error surface. So it is very necessary to any kind of minimizing the functional that is made curve that you need to find the optimum points for your data based on some of the algorithms that is usually is a connection with quantum algorithm, that is gradient descent method. Okay, so you can find this all information here, and or about this algorithm you can use for example least square mean error, and based on the weights, based on the other parameters that you can see here that can be defined for any neural network that you define it. And for more information, I wanted to say about to make a relation between the quantum computers and neural networks. So I will say about what are quantum computers. The quantum computer harnesses some of the almost mystical phenomena of quantum mechanics to deliver huge leaps forward in processing power. So quantum mechanics promise to outstrip even the most capable of today's and tomorrow's supercomputers, and it is very huge topic in the future, and you will find many jobs, many technologies, and many devices in the future that know we are at the beginning of the way. So they won't wipe out conventional computers, though using a classical machine will start to be the easiest and most economical solution for tracking most problems, but quantum computers to pharmaceutical research, also about you will use a lot that till now. So companies things like lighter and more powerful batteries for electric cars, and to help any
Professor, there is a network problem from your side.
create quantum computers, okay, or create new. In order to start about what are the qubits, the secret to a quantum computer's power lies in its ability to generate and manipulate quantum bits, a stream of electrical or optical pulse Excuse me, dear professor. Uh, I have. I need to. Okay, okay. No, I can start again. Let me say. Uh, about the qubits, I want to talk about it. What are qubits? The secret to a quantum computer's power lies in its ability to generate and manipulate those beats, a stream of electrical or optical pulses that represented the one S or 0S, everything from your tweets and emails to your iTunes songs or YouTube videos are essentially long strings to those binary digits. So you have a qubit that you can use any quantum computer to integrate the data or to interact the data. So here which are typically subatomic particles. You need to know the photons move of light, but electrons and positrons move at lower speed in physics, and we have considered all.
Professor Ahmad, there is a time constraint and network problem.
And
Professor Ahmad, you are not audible to me.
okay, do you have my voice now?
Yes, it's fine.
Do you have my voice now?
There are some time constraints and
Okay, okay. So
very
okay,
shortly.
Okay, I wanted to say that these conductive circuits use lots of temperature, so they need to be cooled, and that's why the problem of hot qubits was proposed between physicists and computer scientists. And recently they removed the problem. It is done by trapping individual atoms in electromagnetic fields on a silicon chip in ultra high vacuum chambers. In both cases, the goal is to isolate the qubits in a controlled quantum state, because quantum states are very important for qubits that we will see here. So we need to see about the bracket notation that is very important from Dirac, one of the most important physicists that tried to consider any kind of physical notions for interaction of qubits, interaction of particles and physics together, based on the bracket notation, concise and convenient. Find the symbol here as to present the quantum method as this alpha. This is called a cat so with vector. It is abstract entity. The physical system is in quantum state. We're all in and etc. when represented by the cat operator alpha cat operator. If we have two distinct quantum methods like alpha 1 cat operator, then the following cat we have psi cat operator is C index 1 multiplied by alpha 1 cat operator plus C index 2 multiplied by alpha 2 cat operator. Okay, you will have another find of them. So Ci is a complex number, the possible state for system. So here we have considered a number of linear independent cats required to express any kind of cat that is got dimension of vector space that you can find it in linear algebra. So linear algebra is very important and
Professor Hamad, there is a kind request. Please conclude your talk. There are some time constraint because there are a lot of papers. So please conclude your talk.
yes. Okay. I will take to, my. So you need to know about the Hilbert space. You need to know about some of the vector algebra definitions in order to know these are how these quantum computing is very important notion, and you will find it in many notions that they have considered for you for later study. About superposition, qubits can represent numerous possible combination of 1 and 0 at the same time. This ability is to simultaneously be in multiple states is called superposition. So these qubits they cannot be simultaneously 0 and 1, but they can be just 1 or 0 at the same time. So to put qubits into superposition, researchers manipulate them using a precision laser or microwave beams. Fundamental quantum operators by quantum operator on operands 0 and 1 is by these operators. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. Okay, for it is a superposition. So it's kind of, you can find more information about that. And a standard representation of qubits is representation about in quantum mechanics about these cats be represented by a basis vectors that see zero vector zero cat is one is based on the matrix here that these vectors are usually denoted as zero cat is 1 0 and one cat operator is 0 1. So you will see here the superpositions. Also you will find other information about this, and for a standard representation you will find 0 0 cat 1 0 cat operator 1 0 cat 0 0 1 cat operator and 1 1 cat, and you will find the permutation of one in these vector matrices. Okay, in general n qubits are represented by a superposition state vectors in 2 to the power of n dimensional Hilbert space. And here we have considered a four-dimensional linear vector space. Okay, so the Bell states are important to know in quantum states that we considered here from quantum mechanics. So in quantum information science, Bell states describe a quantum system of two qubits that are maximally entangled. They form a basis of 2 plus 2 Hilbert space where, for instance, each qubit A and B could be a photon with horizontal 0 or vertical 1 polarization. The Bell state is a concept in quantum information science or a specific quantum system of two qubits that represent the simplest and maximal examples of quantum entanglement. So the Bell states are a form of entangled and normalized basis overall probability of the particle being in one of
Dear professor, thanks for your nice talk. It's really appreciable
the inner
for all the audience.
equal to 1. Okay.
Yeah. If there is any question from the audience, please
Yes.
ask any
Okay.
question.
Okay.
Yeah.
Yes. If you have any questions about my presentation about how this make qubits made in the lab in order and qubits and everything that you
I
for
think,
further information to my
yeah, Professor, I
PPT. Yes.
think there is no
Yes.
question from the audience. Thank you very much for your talk and
Thank you
thank
so
you for
much.
your valuable time in this
Thank you
session to make it successful. So now,
so much. Thank you so much.
now
And you will see all.
yeah, dear Professor, now we will share the session
Yes.
and
Okay.
you
Thank you
will
so much.
be
Thank you
with,
so much. And if you have more information,
yes, please.
yes. Thank you so much. Thank you so much for all of the audiences in order to participate
Okay,
in
now we
this
are going to start
great
paper presentation.
area of
Dear Professor, we are going to start paper
research
presentation.
presented by me. Thank you so much, dear professor. Thank you so
Thank you,
much.
Professor. Thank
Thank you
you.
so much for attending this and professors who contributed. So I will say goodbye.
So, yeah, thank you very much, Professor.
So I will say goodbye
Now there is a paper ID 268 is there.
to all of
There is paper ID
Yes, I am
268.
there.
Yeah,
you.
just
Yes,
please
I
1 minute.
am
1 minute,
there.
please. Please wait.
Sir,
Yeah,
can
paper
you
ID
hear me?
268.
Can you hear me, sir?
Yes, yes, sir, I can listen to
Okay,
you.
sir.
Paper ID is 268. Product recommendation using
Yes,
neighborhood-based
sir.
collaborative filtering in e-commerce.
Okay, thank you, sir.
Yes, now you can start and I make you host.
Yes, sir.
Yes, please, now you can start.
Mohammed Hissam Akhtar. My topic recommendation using neighborhood-based. The things which I'm going to discuss here, first I will introduce my topic, then I will discuss methodologies which I have used, that is similarity. First, I will discuss similarity matrix, and then the part of the collaborative filtering, that is user-based and item-based. And after that, I will show some recommendations in which I will show some Python codes also by using user-based and item-based collaborative filtering. And finally, I will show the results. So first, we see what is a product recommendation is actually. See, today in e-commerce, especially, we can see that there are large number of products and items. So it is quite difficult to show all the items to the users. So what we do, we need a technique by which we can give information of the products or items to the user according to their needs or interest. Okay, and for this I have used here the technique, that is machine learning technique, that is neighborhood based collaborative filtering, to recommend products based on items and users. What I have done here basically, if I say that we can recommend product on the basis of user, so if one person will like some products, so there are chances that similar product we can recommend the product or item. And next, what I have used, that is item-based collaborative filtering. So, if
Dear 268 Farid, there is a very big problem from your side of the network. I request you please record your presentation and send to us on the email address. We will consider it, but your recording must be maximum in 12 minutes. Okay, dear professor,
we
because there is a big problem from your side in network. Okay.
hello.
So now, yes, it's fine. I am asking if there is a network problem, you can record your lecture and send to us. We will consider it because, yeah,
So now network is okay. So
yeah.
should I
So
start again?
please continue and do it briefly.
Okay, sir. Sir, allow me to share the screen, please.
Yes.
Thank you, sir. So I was discussing the methodology. I have
Once again, the problem same has been occurred. So it's my kind request, please record your lecture and send to me on my email address. We will consider. Your talk must be maximum 12-minute recording. We will consider that one. Okay. So now there is the next presentation. Paper ID is 267. Weakness of Schindler's secret sharing scheme. Paper ID is 267. Are you present there?
So now can you hear me? Hello.
Paper ID 268. It's my kind request. There is again and again problem from your side due to network problem, I think. So it's again my kind request. You can record your presentation and send to me on my email address. We will consider the same. Okay, dear professor.
Okay, sir. Okay.
Yeah, thank you very much. Thank you. Now there is yeah. I make host ICCTIM 267 paper ID and title of the presentation is Weakness of Shamir's Secret Sharing Scheme. Paper ID 267. Now you are host, you can share. Okay, I think, okay. Yes, please.
Okay. Hello.
Yes, it's fine. You can start and do it briefly with it and finish your talk within 10 minutes, please.
Okay. Hello, everyone. I am Professor Nouri Lamlawal. It is my pleasure to present my work about the security of Shamir's secret sharing scheme. The aim of this work is to answer of the two following questions. First, the Shamir scheme, is it perfect? The second, the Shamir scheme, is it always secure? In general, if a parameter of security scheme belongs to a special class, this system can lose its security. For example, supersingular curves or anomalous curves leads to weaknesses in elliptic curve cryptosystems. The definition of super singular curves is elliptic form such that its order equals p plus 1. The cardinality of finite.
لامصب اون ساعتی که من داشتم کنفرانس میدیدم 30 دفعه قطع شد. الان قطع نمیشه. بذار بیام بیرون دیگه.
The second class of weak curves is anomalous curves. Anomalous curves, it is a curve was cardinality equals p. In the two cases, the elliptic curve character system can be attacked, is weak. In the context of the security of security sharing scheme, it is known that for the scheme of Shamir, an unqualified set of shares cannot leak any information about the secret. This paper aims to show that Shamir's secret sharing is not perfect and it is insecure whenever its polynomial is taken in the special classes. And these polynomials are weak for Shamir's Kn threshold scheme in the sense that they exist if fewer than K shares which can reconstruct the secret. It also showed that for certain threshold K, roughly half of all polynomials of degree K minus 1 are insecure. Finally, to overcome the weaknesses of Shamir's scheme, several classes of polynomials should be obvious. We define the secret sharing scheme. It is a technique in which a dealer distributes shares of a secret S to n participants, P1, Pn, such that the reconstruction of the information S can be done only by the authorized subsets of participants. The secret sharing scheme is widely used for protecting sensitive data. It has applications in various areas, for example, multi-party computation, access control, key management, e-voting. The Shamir scheme is initiated in 1929. Another system is given by Blackley in the same year. The two authors have used Lagrange interpolation and projective geometry respectively. Let Kn be positive integer with K is less than n. Kn threshold secret sharing is a special type of secret sharing scheme where among a group of n participants, only K or more participants can reconstruct the secret. We use the find field of order odd prime P, Fp. Let's P the set of participants, P1, P2, Pn. The first phase is the share distribution. To share a secret S belongs to K. the dealer takes a random polynomial Rx with belongs to K and forms the polynomial fx equals Rx plus S. S is a secret. And give the shares Si equals Fxi to participant Pi, where Xi belongs to the finite field minus 0. The second phase is the share reconstruction. K participant or more can calculate the secrets, for example, by using the Lagrange interpolation and it let Pi1 Pik K participants with their respective shares as I1 as Ik. They put Gx equals sum SEJ LEJ with LEJ is polynomial defined as shown and compute G0 which equals S. In some paper, it is mentioned that every Shamir K threshold sham is perfect. That is, the secret S cannot be reconstructed with K-1 shares or fewer. And this paper, we will exhibit classes of polynomials for which the scheme of Shamir is not skewed. Contribution. First, we recall some definitions and some results. Two integers A and B are coprime if the only positive integer that divides both of them is 1. The Legendre symbol of integer A modulo and not the prime P is 0 if A is divisible by P and otherwise plus 1. The Legendre symbol is denoted by a fraction A over P. So A over P take three values, -1, 0, and 1. And it can be calculated by the Euler formula A power P minus 1 over 2 modulo P. We begin by the threshold K equals 4. Let Fp be find a field of order odd prime P and consider the set of polynomials Rx equals A1x plus A3x power 3, where A3 is not 0, E2 belongs to Fp. If F is a polynomial of degree 3, Fx equals S plus B1x plus B2x2 plus B3x3 is used for Shamir's for n threshold scheme. Let's x1 an element of K minus 0. So Fx1 plus Fp minus x1 equals 2s plus 2p2 x1 2. Then for p2 equals 0, the secret S can be calculated by two shares, Sx1 and x and Sp minus x1. Hence, for every Rx and the previous set, the secret S can be recovered by H of P minus 1 over 2 specific pairs of participants. px1, p minus x1, where x1 is not 0 in fp. Example: let p equals 11, and Rx equals x cubed plus 2x. The first share, the first phase is the share distribution. Take, for example, the secret S equals 6. Then fx equals x cubed plus 2x plus 6, and the shares are computed in the following table, table 1. The second phase is the share
Professor, please present your main work. There is time limitation, please.
Yes, okay. The share reconstruction phase computes S by using the 4 shares S1, S2, S3, S4. We apply the Lagrange interpolation. The second method, the secret S, can also be obtained by each SI S11 minus 1. For threshold k equals 4, there are p minus 1 times p2 polynomials. Among these polynomials, there are p square minus p insecure polynomials. We were interested on threshold k equals 4. We define a set of polynomials of degree 4, and we show that fx1 plus p minus x1 equals 2 before x1 4 plus 2p2 x1 2 plus the 2s equals to this if b2 equals minus x1 squared pcat. In this case, the secret S can be calculated by using the 2 shares. Let's T5 denote the number of all polynomials of degree 4, and we denote by NS4 the set of weak polynomials. We compute alpha, which equals ans5 over T5. We calculate that alpha approaches 1 over 2. That is, for threshold 4 equals 5, roughly half of all polynomials of degree 4 are insecure. Hence, the probability that the random...
Please conclude your work. It's kind request, please conclude your work.
Yes, I go to the conclusion.
Yes.
Conclusion. According to the list subsection, we say that the uniform randomization before sharing is not sufficient to obtain a secure scheme. To remedy the security weaknesses of Shamier's 5n threshold scheme, the trusted dealer must choose the random sequence AI such that only one of the 2 numbers minus A2, A4 is square, because from the multiplicative property of Legendre symbol, we prove the result. other remark. In this example, the possible values of the coefficient A1 are 1, 2, 6. Then they can also obtained by a classic discrete uniform distribution, which is the rolling of die. Thank you. Are there questions? Thank you.
Dear participant, if there is any question from your side, please feel free to ask from professor. Okay, I think there is no question. Professor, I have one question. Can you give any example, real life application of your work?
The first application
Yeah.
is to use to use the Shamir scheme securely. It is not sufficient to take a random. We must add other condition over the coefficients. Hence, we obtained a secure system.
Thank you very much, Professor, and it's a really nice work. There is my student who is also working on it. I think in future I will try to collaborate my student with you. Okay, and I hope our group will support this work in future.
Thank you.
Thank you, Professor. Thank you. Nice talk here.
Okay, thank you.
Now there is a paper ID 241, Gaurav Sharma.
Yes, sir. Present.
268 is now connection is okay. So can I present? Can I continue, sir?
Professor, please just wait 1 minute. After the paper presentation, we will see if there is time. I will consider because there are many presenter here. If there will be more time for us, then I will consider. Okay, so please just wait a few minutes. Now, yes. Now I would like to invite paper ID 241, Gaurav Sharma.
Okay, sir. Please make me host, sir, so that I can.
I will try. Please wait. Yes. Now you are host. You can start.
Okay, sir. Thank you.
And try to finish your talk within 10 minutes.
Okay, sir. I will try, sir. I will try. So screen is visible to me, sir. Yeah.
Yes,
sir?
it is visible.
Okay. So as the sir said, it is a time constraint here. So we will take only 10 to 15 minutes, not more than it. So today I will present my paper entitled Beacon Node Pairing Based Localization Algorithm in Wireless Sensor Network. So first of all, this is the outline that I will go through my session. First of all, I will introduce what is a wireless sensor network and the proposed algorithm. And after that, simulation results will show. So first of all, we have to think, what is the wireless sensor network? So nowadays, everyone thinks things to be automated. And nowadays, like IoT and wireless sensor network, these are prominent technology. And these are the two sides of the same coin. So wireless sensor network is like a system of small, low-powered network sensing devices deployed over area of interest to monitor interesting events. So like for a pollution, if we can take an example, we can place the sensor nodes in the area of interest and we can sense the pollution. And those data can be pushed to the cloud. So like that, these sensors are wirelessly connected because these are self-configurable nodes, and the whole data is placed to the clouds, and there we can access. So like that, nowadays these are happening, and these are come under the technology of IoT, Internet of Things. So that's why, first of all, before going to IoT, we should know what is the wireless sensor network, because in the IoT also we are using the sensors, and we are using the wireless connections to the internet also. So we can use this wireless sensor network anywhere for any application like pressure measurement, heat, air pollution, temperature, anything nowadays for the sliding or forest fire detection. Anywhere we can use, and actually this is in the initial phase. This technology is in the initial phase, and in the developed country it has already implemented, but in India it will take some time. So, as I said, it is in the initial stage. There are so many challenges in wireless sensor network like scalability, fault tolerance, network topology, security, responsiveness, localization. So, I have worked here in localization. So, what is the motivation behind to choose this topic? Like motivation. See here, you can see these two figures. These are suppose a big area, very large area, and suppose we have interested to find the suppose forest fire, and suppose a forest, you know, that is very big forest. If a fire is happened, and if we don't know where this fire happened, so what is the use of that information? So the same thing, if we don't know, means fire has happened in middle of the forest or in that corner or in that location, so that information is totally useless. We can't take any prompt action. So first of all, for everything, the location of the event is very much important. Location of the event is very important. And if we think, okay, GPS is also there, that will give the location, but it is not possible for all the sensor nodes, because we are just deploying the sensor nodes in thousands quantity, like on a mountain or in the forest, and we are just deploying those nodes randomly we are deploying through helicopter or through aircraft, like that. So if we attach GPS, it will consume so much power, and it will die. Those nodes will die within 2 hours or 3 hours. So we have to make the whole system, whole network, which will work with very less power. We are not attaching GPS. So overall, if I conclude, we are trying to find the location of the nodes without GPS. So because our mobile phone is having GPS, but we are daily charging it. But in the forest, suppose we have deployed the nodes, we are not going to charge that nodes. So it is not possible. That's why without that GPS, how we are making the algorithm to find the location of that thing. So this is our aim here. And so this is the thing where anything is happened, first of all this question will come in our mind, where this happened. So this where we can give the answer through the localization. So localization is the technical word in the wireless sensor network, and what it is, to find the geographical location, to find the geographical position of the nodes, is the localization. So there are mainly two types of the nodes: target node and the anchor nodes. Target node means the nodes for which we are trying to find out the location. Anchor node means those locations are already there. Some nodes means out of 1,000 nodes, suppose 20 or 30 nodes are GPS enabled node. So those nodes we are saying anchor nodes. And position also, we can say there are two types of the position. One is the relative position and absolute position. Relative position means we can say beside this room, on first floor, on second floor. This is the relative position. But absolute position means we are talking about the coordinate system, exact position. So localization phases, there are mainly three phases, and these are the classification of the old techniques. So in this one, second technique, as you can see, this is the main thing: range information based technology, and range free technology. So in this one also, range free technology is very prominent one, because we don't need any hardware to find out the range for that one. So again, in that localization, there are so many issues, like a degree of accuracy, how much accurate it will give the location, how much fast it will give the location. So like localization, time changing topologies, like scalability, cost, mobility, so many things are there. So in this one also, very important thing is the degree of accuracy. Suppose if we know the location, okay, this is the location in the forest, but if we don't know the exact one, if we know suppose 10 meters this side or 20 meter that side, that is also not a good thing. So degree of accuracy is the main thing in the localization. So we worked on that one and framed one objective over it. So that to propose a range-free beacon node pairing localization algorithm into the static wireless sensor network. So for it one, we have developed one DV Hope localization algorithm. So it is very famous localization algorithm, and we have simulated over it for various anchor nodes, density of the nodes, transmission range, like that. So what is the DV Hope localization algorithm? So here you can see red color nodes. These are the anchor nodes. Anchor nodes means those are aware about their location, and other nodes are simple nodes, target nodes. So this thing we can see first step is to find the minimum hope counts between the each target node and the anchor node. So here you can see this shaded node and this A1. There is three hope counts like this: 1, 2, 3. It is having also 4, but it will take minimum. So like that, each and every node in the network will calculate the minimum hope count from the anchor nodes. This is the first step. Second step is the estimation of average hope size of each anchor node. Through this formula, they can find out the hope size. Hope size means for this A1. Hope size we are calculating here only for the anchor nodes. Means here 3 anchor nodes are there, red color. So 3 hope size we are calculating. A1, A2, A3. Through this formula, we can calculate. So this is the average hope size for that one. And after that, the estimation of target node coordinates. The main attribute or main factor in finding the location is the finding the distance between the nodes. So main thing is to find the distance. So here we are using trilateration technique. So the as from here you can see Dij, we can find out hope size from hope size, and hope Ij already we have calculated. Through this one we can calculate distance between the nodes. Okay, so these are the distance between the nodes, and if we put in this formula, we can easily find out the coordinates. So this is the typical DV Hope localization algorithm. So what we have modified in this one. So for this one system model, what is that we have considered or assumption we have taken, like all the sensor nodes are deployed randomly. So there are two types of the deployment. One is random deployment, one is the manual deployment. So we are working for the random deployment for a big area. And so anchor nodes are aware of their location by any means, like GPS, or third one, any two arbitrary nodes can communicate with each other by a single hop or the multi hop. So, and all the nodes are having the typical similar transmission power. Fine. So like now this is our proposed algorithm, and we are taking, as I said, a random deployment of the nodes. So all the nodes are randomly deployed over the area of area into interest. First step is anchor nodes first of all floods all the information in this format.
Please conclude the paper.
Sure, sir. Sure. Okay. So main thing what we have done, that is the reliability matrix. So this is the reliability equation. According to the reliability, simple and target nodes will choose the pair of the anchors. Based on it, it will choose the anchors and it will use the trilateration technique. And these are the simulation parameters what we have taken, and you can see, and these are the performance matrices. Means we are just calculating the average localization error, means the positioning error we are calculating, means how much accurate it is. So these are the results. You can see this red color one, this is our proposed one. As compared to other two techniques, it is having very less one, and no more fluctuations are there as compared to others one when we have taken the anchor nodes as a 10%. Okay, and this is the effect of the percentage of the anchor nodes. Means at the x-axis you can see 5% to 40% we have taken anchor nodes. As the anchor nodes are increasing, the localization error is decreasing. As 35% you can see here, only less than 2 meter localization error we got. So it is very useful. 2 meters, it is very much acceptable for that one. And this is the effect of the node density. If we are increasing the nodes, see number of nodes we are increasing here from 50 to 250. Also the localization error is decreasing here. And this one is the histogram plot for the localization error distribution. So red color one is ours one, you can see here, and it is narrow one. Narrow one means it is not having more fluctuations, so errors are lying between suppose like 4 meters or 5 meters only. So these results we got as means with the variations of anchor nodes, anchor density, time also we have calculated. In the very less time we have got the all localization. So this is the conclusion. This BNPCD, this is our proposed algorithm, performed very well in almost all the aspects, and it has improved the localization accuracy about 46% as compared to others one, and it is also very energy efficient algorithm, and it is very less time consuming and more stability as compared to other similar algorithms. These are the references what we have taken, and thank you. So due to time constraint, we have done it very fast.
Yeah, if there is any question from the audience, please feel free to ask from Mr. Gaurav. Okay, I think there is no question. Gaurav, I want to ask one question from my side. Can you please give me any example of your work application in real life?
Definitely, sir. Actually, we are planning to find out the pollution, sir. Pollution in any city. So we are deploying the sensor nodes like a traffic light. Traffic light signals are there. We are just deploying our sensor nodes there, and it is calculating the information in the sense of the pollution in that particular area, and it is sending to that cloud. And the cloud we are just calculating, and we are just finding at this area, or suppose like in any particular area the pollution is more, in this area pollution is less. So we are just plotting the graphs also like that. So it is a practical application recently we are doing, and last year also we have done for landslide prediction in the Himachal Pradesh, for like sometime landslides is there, so for that one also. So different angles we have taken. So it is having more and more applications practically. So this thing recently we are doing for pollution measurement throughout the city.
Good. Really, your work is very nice. I see all the prediction, and there is also some numerical results. Mathematics is also there for verification and to find out errors. Really, I like your work. I hope we will meet in future. It's
Thank
really
you.
great.
Thank you very much, sir. Thanks a lot.
Thank you.
Thanks a lot for your appreciation.
So, next speaker is paper ID 287. Title of the paper is Safety Ring for Danger, Alert and Personal Protection.
Yes, sir. Yes.
Yes, and will be presented by Sylvester. Okay.
I'll share my screen, sir, once again.
1 minute, please. Okay, now you are host and you can share your desktop. Yes, it is visible. And please try to finish your work within 10 minutes because there are time constraints.
So good afternoon, everybody. I am Sylvester John, and I'm doing my third year at the Department of Electronics and Communications at Carney Institute, Coimbatore. I am here to discuss about a project that three of my colleagues, Ashok, Charles Tony, Manchala Vikas, and I worked on. It is a safety ring for danger alert and personal protection. In our society, evil lurks in the form of malice and notoriety. One has to find ways to protect themselves from situations where there's no one nearby to turn to. Tech giants offer a way, but it's out of reach for the majority that can't afford even simple luxuries. These days, it is hard to be separated from our smartphones, a privilege that suffering classes can't dream of. The ones in desperate need for protection find themselves in such cases. We have devised a way to solve that problem. We have designed a ring that can be worn just like any other ordinary jewelry ring. This ring encompasses a GSM GPRS module, which is a SIM 800L module, and a panic button, and can be used during any sort of emergency. A microcontroller, which is basically an 808085, stores 80 commands to make a call to the nearest emergency responses and the mobile number that had been stored as an emergency contact. The ring comes with a rechargeable battery. The ring can hold a 2G SIM card. Actually, you can hold any SIM card, but the operating band isn't 2G. Special services of telecom industries can be consulted specially for this ring. The novelty in this invention relates to a much better way to alert concerned authorities in case of emergency. The ring takes away the dependency on smartphones that could malfunction when needed by simply running out of battery, it could false trigger, and only be afforded by the urban and suburban people. By using the easily accessible telecommunication technology, this ring provides a faster and reliable way of deterrence. There are several ways already available to contact concerned authorities, like through apps and special phone numbers. The smartphone could be really unreliable at times when needed due to slow RAM speed and battery level. From my literature survey, I noticed that there are some rings available for this reason, but they incorporate the need for a Bluetooth module to be connected to the smartphone. This progressively drains battery and needs to be charged continually. Some use tasers, shocking devices, and shockers that are quite illegal in some countries and most of all dangerous. Some authors have worked on GPS trackers. If the coordinates fall in the wrong hands, the safety of that person is compromised. Some authors use bigger microcontrollers, GSM modules, and trackers that need to be charged continuously. But this safety ring doesn't need regular charging as it does not require any battery consumption at idle state. The ring does not require charging until it has been used once. The ring dials emergency contact number and government emergency response services. The ring continuously dials the source set numbers even if the receiver cuts or ignores it. The ring keeps doing so until the batteries die or the button has been turned off. An LED indicates that the ring has been activated. The ring continues to call for approximately 5 minutes, giving enough time for call tracing and triangulation of coordinates. The 801085 microcontroller is one of the small and high performance AVR microcontrollers, which is based on RISC CPU. It is one of the 8-pin microcontrollers that comes in two packages used to control an interface between different devices and sensors. It comes with a 10-bit ADC and MSSP. 801085 is one of the low power consumes very low power and has a small sized memory with only 8 kilobyte flash memory and 512 bytes RAM, which is more than enough for instruction code. The SIM800L module is a GSM module. It is a small chip that uses serial communication to communicate with any microcontroller or microprocessor. It has an inbuilt onboard antenna and onboard SIM slot for SIM insertion purposes. The SIM module has 12 pins that are used to establish connections with the microcontroller. We use a micro SIM over here, which we can use any SIM, 2G, 3G or 4G, but for telecommunication purposes, only for call purposes, the voice over LTE falls back to 2G. In the age of 5G, there's a question, is 2G really necessary? I mean, is 2G even supported anymore? Well, in India, Apple has over 135 million 2G users. Vodafone has over 174 million 2G users. This survey was taken at the end of March quarter in 2020. European countries like Netherlands, Sweden, Norway, Russian Federation, etc. still support 2G. Several service providers in Asia like Pakistan, India, Malaysia, Myanmar, Nepal, etc. still use 2G. T-Mobiles and Movistar are telecommunication providers who support 2G in the US. Most parts of Central and South America still depend on 2G. And the biggest bombshell is many modern LTE-enabled devices are still known to fall back to 2G for phone calls. The battery circuit comprises of two lithium polymer rechargeable batteries, each of 3.7 volt and 180 mAh. Based on the overall consumption of power of all components, the batteries discharge in 5 to 6 minutes. This allows the ring to keep calling until responded until the batteries die out. This we can calculate from the formula battery life is equal to the mAh rating of the battery divided by amps consumed into 1000, which is in hours. As you can see in the source code, the phone number is provided over here. The phone number of the emergency contact or an emergency number can be added for contacting the emergency responses. And you can see after a delay of over 50 seconds, the number redials. The ATH is the command to redial the number. So the microcontroller keeps redialing until responded. Once the call is connected, this call can be easily triangulated. The Arduino Uno is used to program the 801085. Actually, this microcontroller need not be specially programmed using an expensive programmer kit. The Arduino Uno that simply lies around in everyone's house for any engineer's house can be used to program it. That's simple. The 801085 VCC is connected to two 3.7 LiPo batteries and the push button switch in series. The VCC of the SIM 800 module is connected to the same. The entire paraphernalia is placed in a hollow mold that can be worn as a ring. The pin 3 of 801085 is connected to the TX of SIM 800L and pin 4 of 801085 is connected to the RX of SIM 800L. Two batteries are used in series, indicator LED and push button switch, and also the SIM 800L and 801085 power modules all are connected in series. So once the button is pressed, everything turns on at the same time. When it's not pressed and idle, the battery circuit is incomplete and the battery does not discharge, so the battery holds its life. Two resistors, 1 kilo ohm and 2 kilo ohm for a volt, are used for a voltage divider network to obtain 5 volt constant VCC for the two LiPo 7.4 battery to obtain 7.4 volts and divided to 5 volts. A 1N5400 diode is used to drop the voltage from 5 volt to 3.8 volt for the SIM module. The GSM module operates at a baseband. The button is so designed to avoid false triggers under accidental pressure due to uneven surfaces. The mold around the circumference of the button is raised in ellipsoidal fashion to raise the button from such surfaces. The ring also gives a grace time of 10 seconds before the first call is sent. This is to redeem a false trigger. The ring has a port with 6 pins encompassed through which the coding and phone numbers can be updated. At the opposite side, you have only 2 pins through which the ring is charged. It also has a port with 2 pins to allow charging. The charging dock comes separately. It comprises of an 8 volt 0.5 ampere adapter. The ring has 2 pins on the other side. Yeah. During this time, the battery is disconnected from the GSM module because the button remains off. This is a simple layout of what really happens. This is the algorithm. When the button is pressed, when the contact is established, the whole circuit is complete and the microcontroller simply dumps the 80 commands into the GSM module, and after around 10 to 12 seconds, the GSM module contacts and then the battery level is checked. If the battery level is high, still remains high, the call continues. Otherwise, it simply turns off. So this is the simple layout of what really happens. And now for the charging part. As you can see, from the total 6 pins of charging and the programming, the VCC and ground are the first and 6th pin. The 4 pins are used to charge, the 4 pins in the middle are used to charge the ring and to program the microcontroller. This is basically the charging layout and how it's performed. Now, will it all fit inside a small ring and will it be comfortable to wear for any person? The dimensions are the SIM 800L has a size of over 15.8 into 17.8 into 2.4 millimeters. It weighs around 1.35 grams. The microcontroller's dimensions are 8 cross 4 cross 2 millimeters and it's only 0.5 grams. The 3.7 LiPo batteries each has a size of over 3 centimeters into 2 centimeters into 4 millimeters. It weighs around 2 grams. And the plastic ring mold itself, the overall size of the central disc that holds the entire circuit is 3 millimeters in diameter. The ring's outer diameter is 40 millimeters and its inner diameter is around 35 millimeters, and the whole thing weighs around 5 grams. In conclusion, the ring hold
Please conclude.
is sir. In conclusion, the ring encompasses components that are reliable and foolproof. The design of the ring ensures that the wearer is protected from all kinds of social evils like kidnappings and molestations. A sense of safety will linger in the wearer's mind, knowing that should any misfortune befall, the loved ones and the government authorities of the wearer would be alerted in an instant. This innovation ensures that the need for smartphone dependence is removed, thus making it affordable for all classes of society. Thank you, sir.
Any question, please?
Sir, may I ask one question, sir?
Yes, please, you can ask.
Mr. Sylvester, have you designed it practically or it is just an idea?
No. I've actually worked on this project with my friends before the lockdown, and it did work, sir.
No. Actually, you are showing in the second last slide that SIM 800L, that GSM module is of 1.35 grams. Before it, one slide is there. I have also worked on it, but weight you have written wrong here. 1.35 gram is very, very less, and SIM 800 module list
No,
dimension
sir.
also.
You can cut out the paths that you don't need because we are using only RX and TX from this circuit.
Yeah, definitely. But as you are saying, Arduino, you are using, but that
No,
size
sir.
also you didn't mention. Huh?
No. I'm not using Arduino Uno here. I'm using 8010 85 microcontroller, which is
Okay.
very small. It's smaller than your coin, sir.
No, but where you are using GSM, GPS, where you are using then?
No. I'm not using a GPS module. I'm using the SIM 800L module and the 8010 85 microcontroller. If you check online, you can see the dimensions, sir. This all
Okay.
can fit inside a ring.
Because I am having a doubt on this, the current consumption, because LiPo battery you are using 3.7 volt and GSM is
Yeah.
consuming 100 to 200 milliampere when it is
No,
receiving
sir.
a
It
signal.
consumes 2 ampere. Transmission burst is 2 amperes.
No. 100 to 200 milliampere. At 2 ampere, you are saying 2 ampere is too much.
No, that's for
Milliampere.
transmission. No, I worked
Yeah.
on it and I calculated, sir. It actually consumes 2 amperes for transmission burst. For the
2
first,
ampere.
when call is made,
Just think over. 2 ampere is too much. 2 amperes you can see very heavy loaded AC appliances we can work. 2 ampere.
yeah, sir. I mean, the
Milliampere.
maximum
You
current that
just
it
correct.
consumes.
You just correct your word. It is 2 milliampere. You can say 2
Sir,
ampere
but
is.
I checked it out, sir. I made the calculation and we got this result. That's why I'm explaining this. Otherwise, I wouldn't have confirmed it.
Okay, time is very less. Otherwise, you just check 2 ampere is not possible. 2 ampere, we are not working anywhere in this small devices. 2 ampere, AC devices we are using like our emergent rod, AC is over our 2 ampere. Then how you are working on a small ring that is in hand of 2 ampere? 2 ampere means it will be blast.
No, no. That's a transmission coverage. The time it takes is
Definitely, dear.
very small. It's
Definitely, dear.
infinitesimally small. The transmission is that much. I mean, the once the call is made, as you said, it consumes over 100 milliampere and 200 milliampere. Yeah, that range is there. But
No,
initially, the
you didn't
first
catch
time when
my.
the call has to be sent.
You didn't catch my point. What I want to say, 2 ampere. You are saying 2 ampere is too much current. 2 ampere is too much
Yes,
current.
sir. That's not a constant current consumption. It's not going to consume 2 ampere all the way. We need to consider only the transmission burst, which is only for over a millisecond or 2 milliseconds. For that, the battery should be capable enough to handle that much. And how long does it take? That's what I calculated as around 5 to 6 minutes. And once the first instant of the call is made, it consumes over, as you said, 100 to 200 milliamperes constant. That we are not concerned about, sir.
Okay, but I want to say you just check it. If you apply Ohm's law here, V is equal to IR. I is here 2 ampere you are saying, and if you are saying the heat also, it will be too much. 2 ampere means
Yeah,
too.
sir. Yeah. Yeah, that's not a constant. That 2 ampere is, as you said, it consumes a lot of, it creates a lot of heat, I square RT. Yeah, but the thing is that T value also matters here. This is only for a millisecond
You said
because
na
it's
5
for
to
the
6 minutes.
initial transmission burst. No. That 6 minutes is for 100 milliampere, 200 milliampere range, as you said. That is for constant calling. But the first second of call burst, that it's called a transmission burst. The first second it consumes a high current, that is 2 ampere or something.
That's why
But
it is having three
after
phases.
that,
Yeah.
it goes down. It goes down to 100 to 200 milliampere because it does not need that much current to continue calling. At the first instant, the first second, it consumes 2 ampere. First second.
Okay.
So that's why I took the worst case complexity and calculated with the high current. That's why, sir.
Yeah, it's a really nice discussion, and your presentation is also really applicable in our daily life. Now I announce some more paper ideas. Uh, 208 is present here. 208 246, 235, 236, 215, 258. If anyone is present here, please raise your hand. Anyone, please? Okay, I think no one is here. Okay, I think all the presenter has present their paper. Now 268. I can give you time.
Yes, sir. Sir,
Yeah.
can I start?
Yes, you can start and you have only 10 minutes. Okay, within 10 minutes you have to finish.
Okay, sir. Fine. Thank
Yeah.
you. Sir, make me host, please.
Okay. 1 minute, please. Okay, now you are host. And please try to finish within 10 minutes.
Okay, sir. Okay. So filtering in e-commerce. Filtering is the machine learning algorithm. And first, I would like to introduce the topic. First, we'll see what is product recommendation is actually. This is the information to give the users. As we can see that there are hello. Hello, sir. Can you hear me? Hello. Sir, can you hear me?
Sir, your voice is breaking, sir.
Hello. Sir, can you hear me?
Yes, sir. Now it is okay, but when you are presenting, your voice is too much breaking, sir. It is not audible to anyone, sir.
Yeah, your voice is really breaking many times.
Sir, should I start again?
No,
If
please,
you allow
because
me, please.
network from your side is very low. It's my kind suggestion that if it's possible for you to record your talk and send me on my email address, it will be fine for me. And now it's time to close the session. Thank you all of the participants who present in the session your paper. And the papers which are presented here are really good work, and best wishes to all of you. Thank you very much.
Thank you very much, sir. Thank you.